Hello everyone, welcome back to our class here at csecmathtutor.com. In this video we're going to be talking about inverse functions. Inverse functions are interesting functions to start with, and one of the questions we may ask is, what is an inverse function? Well, let's explain it this way. Suppose we have a function f of x which is equal to 2x plus 3, and we interpret it as start with x, multiply by 2, and then add 3. So we start with x, we multiply x by 2, and then we add 3. Then the question is, how do we reverse this? And if we want to reverse it, what would it become? Well, to reverse it, we'd have to do the last thing first, and we have to do it in reverse. So the last thing we did was to add 3. So the first thing we need to do was to minus 3. And then the second thing we did here was to multiply by 2. So what we have to do now is to divide by 2. And since we're dealing with our letter x, then you see it here. So as in x, we multiply by 2, we add 3, then we start with opposite, we subtract 3, then we divide by 2. The inverse function is the function that reverses whatever a function does, and perhaps this is the best way to say it. Whatever a function does, the inverse function reverses it. So if you have a function, say, that maps a onto 3 and b onto 1 and c onto 2, as you see in the diagram here, then this is your function f, then f inverse is going to reverse it. The domain will become the range, and the range will become the domain. And I should point out here that not all functions have inverses. The very fact that not everything can be reversed means that sometimes you're going to have a function where when you try to reverse it, you run into situations that it can't. Or if you choose to reverse it, you have to pick parts of the domain for it to work. But the idea is, for an inverse function, that you should remember is that the inverse function will map the range back to the domain, in that it will reverse whatsoever the function does. Let's look at how we can go about finding our inverse function. Now, the inverse function can be found by first replacing our function f of x with y and changing the position of the letters, that is, switching our x and our y positions. And the third step here would be to solve for y. And once we've solved for y, we can replace our y with f inverse of x, and that would be sufficient for finding our inverse function. We may check our work when we are finished, but it will not always be necessary to check our work. But once we have done this, 1 to 4, and we have done it correctly, then we would have found our inverse function, and we can try that. We can practice some examples and see how that goes. As usual, the questions that we practice from are from CSEC papers, so we can get a feel of the type of questions that CXC writes and how you're expected to deal with them. So the first question here says, obtain an expression in x for h inverse. And I'm starting off with perhaps the most difficult one. And h inverse of x is equal to 2x plus 3 divided by x minus 1. First thing what we're going to do is to write the function and let it be equal to y. So 2x plus 3 over x minus 1 is equal to y. Then we're going to switch the letters x and y. So here we're going to have 2y plus 3 over y minus 1 is equal to x. And now that we have done that, we can solve our equation now for y. We can do a simple cross multiplication here, or we can multiply both sides by the denominator, which is y minus 1. So we can say y minus 1 times 2y plus 3 over y minus 1, which is the better explanation. You could cross multiply it, it would work just the same. X times y minus 1. On this side, we get 2y minus 3, 2y plus 3 rather. And on this side, we get x times y minus 1. Now, let's multiply out this. Let's bring it up here to get some more space. So we have 2y plus 3 is equal to xy minus x. Now, right away we notice that we have the y on both sides and we're trying to solve that equation. So we will need to regroup our y's. So we start off by regrouping this xy on this side. It becomes a minus xy. And we had a minus x there. Regroup this 3. It's a plus 3, so it becomes a minus 3 there. So now we have our y's on the same side, and we can factor out our y. So we end up with 2 minus x is equal to minus x minus 3. And having done this, the last step here is to divide by our bracket. So we have y is equal to minus x minus 3 over 2 minus x. And this here is our inverse, h inverse of x. So what did we do first? Let the function equal to y. Then we switch the positions of x and y. Notice x is here, y is here. Now we switch them. So now we have y here and x there. Multiply by the LCM in this question. The LCM is y minus 1. So we multiply both sides by y minus 1. Or you could, of course, cross-multiplied it. And here, this cancels out, leaves us with 2y plus 3 is equal to x times y minus 1. Multiply that out. X times y minus 1 gives us a xy minus x. And once we remove the bracket, we can reorganize or regroup our equation. So we regroup our xy on the right-hand side, on the left-hand side of the equation here. And we take this positive 3 to the right-hand side. Once you've done that, then we factor this out. And once you factor out the y, you get 2 minus x here. And divide, and that becomes our inverse function. Let's try another example. Here we have g of x is equal to x cubed, and g inverse of x is what we want to find. So we say x cubed is equal to y, and then we switch them to say y cubed is equal to x, and now we need to solve for y. Now, how do we solve for y when we have y cubed? Recall that if you have an equation x squared equal to 25, then the way that we solve it is to find the square roots of both sides. So the square root of x squared would equal to the square root of 25, which would mean that x is equal to plus or minus 25, the square root of 25, which is 5. Since we normally look at the positive square root, we normally say x is 5, but generally plus or minus. So in this case, we are going to be looking at finding, since this is a 3 and not a 2, a cube, we're finding the cube root, and we find the cube root by saying y is equal to, put a 3 there, the cube root of x. And now this becomes our inverse function. So the g inverse of x is going to be equal to the cube root of x. And that is how we do this one. And let's look at this one over here. So g of x is equal to 5x plus 3. So we write our function 5x plus 3 is equal to y. We're going to switch them now. So we're going to have 5y plus 3 is equal to x. And now we're going to be solving it for y. Recall that in solving equations such as 2a plus 3 equals 10, then what you do first is that you do the opposite of that. We're adding 3, so you do the opposite of adding 3. So 2a would be equal to 10 take away 3. So the first step we're going to do here to mirror this is to say 5y is equal to x take away 3. So we would have finished that part and gotten 7. And having gotten to here, the next step would be to divide both sides by 2. And once you divide both sides by 2, then you get your a is equal to 7 over 2. Now, it's the same thing that we're going to do here. We want to find our y, so we divide both sides by 5. So 5y over 5 is equal to x minus 3 over 5. And therefore, y is going to be equal to x minus 3 over 5. And this is our function g inverse of x. So, if it's a power, then we need to find the root of that power. If it was x to the fourth, for example, then you'd have to find the fourth root. If it was x to the fifth, you'd have to find the fifth root, etc. When it's regular equations like these, we perform a regular linear solution, which entails just doing the opposite of what that is doing, which is here it's to subtract 3 because 3 is being added there, and then proceed through dividing by 5, and we have our inverse solution. This would be the inverse of the function f of x is equal to 5x plus 3. More examples. Here we have h of x is this and k of x is that, and we're asked to do two things. One, find hk of x, which is a composite function. We looked at that before. So to find the composite function, what we're going to do is write the first function first, that is h of x is equal to 1 plus 3x, and k of x is equal to x plus 2. And now we're going to take this x plus 2 and put it for x in h of x. So h of k of x is equal to 1 plus 3 times x plus 2, which gives us 1 plus 3x plus 6, which gives us 7 plus 3x. Now that we have our h of k of x, the question now is to find the inverse of h of k of x. So h of k of x is equal to 3x plus 7, and we want to find the inverse. So we say let 3x plus 7 equal to y. And once we have decided to let it equal to y, then we switch the letters. 3y now plus 7 is equal to x. We are now going to solve this equation for y. We have a plus 7 here, so we're going to subtract that 7. So 3y is equal to x take away 7. Once we have done that subtraction, 3y therefore is going to be equal to x minus 7 divided by 3. And our solution, having cancelled there, y is equal to x minus 7 over 3, which becomes h of k inverse of x. Let's look at some more examples. Here we have f of x is equal to 3x minus 5 and g of x is equal to a half x. And we're going to find f inverse and g inverse. And as a third part of the question, we want to look at what the inverse of that is, of the composite function is. So let's ignore this f of negative 3 for now. And let's work on part B that says find f inverse. So f of x is equal to 3x minus 5. We're going to write 3x minus 5 is equal to y. Then we're going to switch the letters. 3y minus 5 is equal to x. And then we're going to solve it for y. Solving for y gives us 3y is equal to x plus 5, and dividing by 3, we end up with y is equal to x plus 5 over 3, which is the same thing as f inverse of x. To find g inverse of x, part 2, we write g of x, and g of x is equal to a half x. Once we have that g of x is equal to a half x, we can write half x equal to y and switch them. So it becomes half y equal to x. And to solve this here for y, we simply need to multiply both sides by 2. So multiplying this side by 2, 2 times a half y is equal to 2 times x. 2 times a half will give us 1. So we end up with 1y is equal to 2x, which becomes g inverse of x. Now, this question down here says find, hence or otherwise, write an expression for g of f inverse of x. We have two options to do that. One, we can find the composite function g of f first, and then we can find its inverse, or we can combine these two inverses to get our answer. Let's take the easy way out for now. G f inverse of x is the same thing as f inverse g inverse of x. Notice that the letters are turned around. So g of f, the composite function, the inverse of that, when we find the inverse of that composite, is the same thing as reversing the inverses in a composite form. So we can write, take note of this, because this is something that will pop up every now and then on a CXC paper. So if you're asked to find the inverse of this composite, it is the same thing as using the inverses if you had them already, and write them in reverse order. So f inverse is going to be x plus 5 over 3. So f inverse x is x plus 5 over 3, and g inverse x is going to be equal to 2x. And so what we're going to do is to take our 2x, and since we're making a composite, because this is a composite, we're going to put a 2x right here, substitute it. So f inverse g inverse of x would become 2x plus 5 over 3. Let's try another one. And this question here is similar to the question that is on this side of the paper. We have two functions. F of x is x plus 3, x over 3 plus 1, and g of x is 2x minus 1. So the first thing, we're going to see it plainly now here, why that was done a while ago. F inverse, let's write down f of x is equal to x over 3 plus 1. So we let this equal to y, and we switch the letters. So now we have y over 3 plus 1 equal x. And now we're going to solve it for y. The first thing we need to do is to multiply everything by 3 to get rid of this 3 in the denominator. So we're going to multiply by 3. So 3 times this, and 3 times that, and this times 3, which gives us, that cancels out. So we end up with y plus 3 is equal to 3x. And then solving for y, we just need to write y is equal to 3x, take away 3, and this becomes our inverse function for f. Now, g inverse, we start by writing down g of x is equal to 2x minus 1, And we're going to say, all right, let that equal to y. Then we switch the positions of x and y. So 2y minus 1 is equal to x. Having done that, we can simply solve for y now by removing this negative 1 to the other side of the equation. We end up with 2y is equal to x plus 1. And dividing by 2, y will be equal to x plus 1 over 2. And this here is g inverse of x. So we have our inverses. We have f inverse, which is this, 3x minus 3. We have g inverse, which is this, which is x plus 1 divided by 2. That's part 1 and part 2. And now we need to find the composite function f of g of x. So f of g of x, part 3, f of g of x. F of g of x is found by substituting the function. It's a composite function. So we're going to substitute g of x into f of x. So f of x is equal to x over 3 plus 1. G of x is equal to 2x minus 1. So we're going to substitute this here. So f of g of x, let me write that better. F of g of x is going to be equal to 2x minus 1 over 3 plus 1. That's part 3. Now for part 4, we need to find the inverse of this. And to find the inverse of this, we simply let it equal to y. Then we switch the letters, so y becomes x. So we have 2y minus 1 over 3 plus 1 equal x. And now we're going to be solving it for y. First thing to do is to multiply everything by 3 to get rid of the denominator. So we multiply by 3, that's section by 3, the 1 times 3, and the x times 3. Here it will divide itself out. So we end up with 2y minus 1 plus 3 equal to 3x. And this gives us 2y plus 2 equal to 3x. Now we need to divide by saying bring this over or subtract 2. So 2y is equal to 3x, and then y minus 2, and then y is equal to 3x minus 2 over 2. So this is part 3, where we find the inverse of the composite function that we found. The composite function to part 3, this is the answer to part 3. Let me highlight it. And now we need to, down here, find the inverse of that. And the inverse of that is this. So part 4, the last part of the question to finish it, it says fg inverse, that is the inverse function that we just found of x, is equal to g inverse x, f inverse x. And remember, we have found this. Here it is. So we're going to show that 3x minus 2 over 2 is the same result as putting the f inverse function into the g inverse function. Now, what was the g inverse function? G inverse function was x plus 1 over 2. So let's write x plus 1 over 2. That was our g inverse. Here it is. And we're now going to substitute the f inverse. Now, what was the f inverse? F inverse x was 3x minus 3. So we're going to substitute this right here for x. And that is going to give us 3x minus 3 plus that 1 over 2. And as you can see here, 3x minus 3 plus 1 gives you minus 2 over 2. So the two functions are equal in the sense that because we get the same result. So the inverse function here, 3x minus, finding the inverse of the composite. Here's our composite, and then we found the inverse of the composite. Finding the inverse of the composite is the same thing as switching the letters in the composite. If you already have those inverses, you don't have to go to the trouble of working it out that way. You can drop the F inverse into the G inverse, but notice here in the bracket that it says F then G. So when you're working it out that way, you have to turn it around and say G then F. So you're going to drop F inverse and G inverse. Let's go back to the question earlier. So it says hence or otherwise. When a question says hence or otherwise, it's an implication that something that you have done can be used to do something that you're about to do. Now, if you know how to do it, fine, which is the hence, you can proceed and just write it out like this. If you do not know, then the other thing to do would be to find the composite function first and then find the inverse of it. So remember that if you have a composite function g of f of x, and you are asked to find, and you found individually g inverse x and f inverse x, and now you're being asked to find the composite of the inverse of this, then since you have these two, what you can do is just reverse the order of the letters and say g inverse g of f inverse x is the same thing as dropping f inverse x, dropping your g inverse x in your f inverse x. All right, let's go back and see what's going on. So we have another example here, which is not as difficult as those. So let's try this one. So f of x is 2x minus 7 over x, and we want to find the inverse. Let's write it down simply. So we say 2x minus 7 over x is equal to y. We're going to switch those letters. So we have 2y minus 7 over x over y, again, equal to x. And now we're going to solve this equation for y. Immediately we realize that y is here and y is in the denominator. So we're going to multiply both sides by y. So let's multiply both sides by y. When we multiply both sides by y, this cancels out here. So we're left with 2y minus 7 there is equal to xy there. If you want to remove the negatives and make it all positive, then we can regroup this xy over here. So we have 2y, regroup on that side, we end up with a minus xy, and this minus 7 is regrouped on that side, it becomes a positive 7. Once we've done that, then we can say, all right, factor out the y. So y factored out gives us 2 minus x, and that is equal to 7. And once we finish that, we're pretty much done. So y would be equal to 7 over 2 minus x, and this is your inverse function, f inverse of x. Here's another one. H of x is equal to 10 over x minus 3. So h of x is equal to 10 over x minus 3. We make that equal to y. Then we switch our letters. So we have 10 over y minus 3 is equal to x. We have switched our letters, and now we need to solve for y. Y is in our denominator. So let's multiply both sides of the equation by y. So we multiply there by y, here by y, and here by y. This side here, it cancels out. So we have 10 minus 3y equal xy. We need to regroup. So let's keep our 10 here is equal to xy plus 3y. And once we've done that, then we can factor out our y. So 10 is equal to y. Factor it out, we end up with x plus 3 there. And having done that, we can complete by saying 10 over x plus 3 is equal to y, which is equal to our h inverse function. For many students, finding the inverse function can be difficult because it involves a number of things. And one of the things that it involves is, one, you need to be able to solve linear equations. So your equation solving skills need to be good. Well, you need to be able to solve equations in general. Two, you need to be able to work with algebraic fractions. Anywhere in this situation you have a weakness with any one of these, you're going to have a problem enjoying the topic or mastering the topic of inverse functions. And it's the same thing for changing the subject of a formula. Both of them are related. Changing the subject of a formula is pretty much the same thing as finding inverse functions. They have a lot in common. So you need to be able to solve linear equations or to solve equations in general. You need to be able to work with algebraic fractions efficiently. And third, you need to be able to factorize using the highest common factor. You need to know, you need to at least know these three things. Once you know these three things, your ability to solve those kind of questions will be greatly enhanced. If you struggle with these, you're going to struggle with finding the inverse function. So before we go, let's look at one more example. Or let's look at two more examples. Let's say our function f of x is equal to 5x minus 1, and we want to find f inverse.